Unit 12, let's talk about solving quadratics with square roots. So the goal here is to get this part all by itself because it is something that is squared. We do that by subtracting 25 from both sides. We're left with this value, which is perfect because 25 happens to be a perfect square. Now we go like normal, where we take the square root of the left, it cancels out the square. We take the square root of 25 and it's 5. But there's one thing we're going to add here, and that's a plus minus, because there's actually two values that if you multiply them by themselves give you 25. 5 times 5 works, but negative 5 times negative 5 works as well. So that's kind of like saying either x plus 2 is 5 or x plus 2 is negative 5. That's what the plus minus means. It can be either one. So if I subtract, I get 3 or negative 7. Those are the two values that make this equation true. While you could use other methods to try to solve this quadratic, because it is so nicely set up with a square and a perfect square over there, this is a great technique. Let's try it again with something that at a glance might look a little bit messier. It might look like we have some fractions and we're going to have to simplify and reduce and do a lot of work here. However, if you stop at this point and recognize that you can split your squares like this, that's going to work out pretty well. Because on the top I'll have a 6, on the bottom I'll have a 4, and remember I'll have a plus and a minus. So there are two different answers there. Now, 6 over 4 is an actual number. That's the same thing as like 1.5. That's not an irrational number. So we could actually keep solving this and write that 9 minus 2x is equal to 1.5, or 9 minus 2x is equal to negative 1.5. If we subtract 9 from both sides for both equations, we have negative 2x is equal to negative 7.5 on the left and negative 10.5 on the right. Both of these I will divide by whatever's in front of x, which happens to be a negative 2 here. Don't forget to bring the negative with it. And these are my two possible answers, negative 3.75 or 5.25. And if you wanted to keep it in fractions like Delta Math liked you to do, you could always press Math, Enter, Enter at the end and find the fraction form. Sometimes, however, if you try this method, you'll run into a situation like this. Once you get the square part by itself, you don't have a perfect square on the right. That doesn't mean that you have to stop and use another method. Here's what you do instead. You just leave it as the square root of 10. Because you can't simplify it, you just write plus minus root 10. And in some ways that makes the problem a little bit easier even. You don't have to bother to find the two answers. You just say that one of them is negative 6 plus the square root of 10, and the other is negative 6 minus the square root of 10. And that plus minus allows you to show both in one line of text. The next thing we learned was how to find the discriminant. So if this is a quadratic in standard form, you'll see that it's ax squared plus bx plus c is equal to 0. And I see the 0 there. I have an a value of 6, a b value of negative 1, and a c value of negative 6. I'm going to use the discriminant formula, which is b squared minus 4ac. If I do this with parentheses, I can do this on my calculator quite easily. Negative 1 squared, that's the b, minus 4 times 6 times negative 6. If you do it correctly, you get 145. The most common mistake is people forget the parentheses here, or they use a negative here when it should be a subtraction, or vice versa here. Those are the common problem areas. Practice doing these on the calculator to avoid making those mistakes. Here's another one. A is negative 9, B is negative 1, and C is negative 5. So I'm plugging them into b squared minus 4ac. That's negative 1 squared minus 4 times negative 9 times negative 5. This gives me negative 179. So sometimes your discriminants will be positive, sometimes they'll be negative, and it's even possible for them to be 0. Here's where some students go wrong. They try to start plugging in A is 4, B is 6, and C is 9, and go on their merry way to find the discriminant. But the problem is this is not in standard form. If it was, it would look like this. So we have to actually move this 3x squared over. And once we do that, now we are in standard form. So A is 1, B is 6, C is 9. If we plug this into b squared minus 4ac, that's the same thing as 6 squared minus 4 times 1 times 9. If we plug that into our calculator exactly as written, you get 0. So what does it mean to have a positive answer, a negative answer, or a 0 for the discriminant? Well, it turns out if your discriminant is positive, that means your quadratic has exactly 2 solutions. If your discriminant is 0, that means your parabola only touches the x-axis and there's 1 solution. And if your discriminant is negative, that means there's 0 solutions. Your parabola never touches the x-axis. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. To the tune of pop goes the weasel. There's your formula. I would encourage you to have that in your notes and have that just something that you can pull up. Here, for this problem, we pull these a, b, and c values. So we can write it like this and then plug in a negative 14 here and there, an 8 here and there, and a 5 there. Where do you begin? Well, I like to simplify this part here because that's the discriminant. And if I do so, I get 36. So let's clean this up a little bit, and I'm going to write 14 plus or minus the square root of 36 divided by 16. This is the same thing as saying 14 plus or minus 6 over 16. So 14 plus 6 over 16, 14 minus 6 over 16, that's 20 over 16, or 8 over 16. This one's going to be 1/2, and if I press the math enter key, I will turn this one into 5/4. There are 2 solutions that make this equation true. If you plug in 5/4 for c or 1/2 for c, it comes out as 0. Like the discriminants here, we have to move the plus 3 over. Once you do so, you have 9d squared plus 12d plus 4 is equal to 0, and now it's in standard form. So a is 9, b is 12, and c is 4. So consider this as your formula, and I'm going to set it up like this with parentheses and plug these things in. 12 is my b value, I can plug it in there. 9 is my a value, and 4 is my c value. I like to start by simplifying what is inside the discriminant, not including the square root, just in the calculator using parentheses. Good news here, that gives me 0. So I have negative 12 plus or minus the square root of 0 divided by 18. Now adding 0 or subtracting 0 doesn't change anything, so this is negative 12 over 18. If I simplify this, I get negative 2/3. There's only one answer for this one. When your discriminant is 0, you only have one answer. It's possible, too, that when you are solving these, you won't have perfect squares. If you have 5w squared minus 11w plus 3 is equal to 0, a is 5, b is negative 11, c is 3. And if you plug those in, you have negative 11 plus or minus the square root of negative 11 squared minus 4 times 5 times 3 all over 2 times 5. If you simplify this, you get 11 plus or minus the square root of 61 all over 10. Now, since you can't simplify the square root of 61, you can just leave this as your answer.